Hello there, and welcome to the Sleepy Space Channel. Tonight, we'll be drifting into the long and patient quiet that lives between the stars. There is a kind of travel that has nothing to do with speed, a slow crossing of light years, accompanied only by distance, patience, light, and time. 5 small machines are already out there, moving through the dark beyond the sun's reach, carrying golden records and the memory of Earth. And somewhere beyond them, in the space where no ship has yet traveled, the nearest star waits, more than 4 light-years away, its light already on its way to you. If you enjoy these gentle journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here too. One sleepy soul at a time. But for now, there is nothing you need to do but settle in. Let your shoulders soften. Let your breathing slow. Allow your eyes to grow heavy and let the day fade away behind you like a star slowly shrinking in a window. Let's begin. There is nothing you need to remember tonight. There is nothing here that requires your full attention, nothing that needs to be held carefully in mind or followed with effort. You are allowed, right now, to simply let these words arrive the way distant starlight arrives without announcement, without urgency, settling softly at the edges of your awareness, like the last dim glow before a room goes fully dark. The universe is already quiet. It was quiet long before we began imagining it, long before we gave names to the stars or drew lines between them in the dark. Space does not require our attention to continue its slow and patient work. It moves on its own timescale, which is so much longer and so much gentler than our own, that simply remembering it tends to loosen something in the chest, tends to soften the edges of whatever the day has left behind. Tonight, the subject is interstellar travel. But that phrase, said quietly, means something different from how it might sound in the daylight. It does not mean rockets and speed and the drama of departure. It means the space between suns. It means the long, uninterrupted quiet that exists between one star and the next. It means patience as a physical condition of the universe, and distance as something you can simply drift through without forcing it, without hurrying. You can let your eyes close now, if they haven't already. There is nothing to see that the imagination cannot provide more gently. Behind your closed eyes there might be a sense of dim stars, very far away, arranged in no particular pattern, simply present, simply glowing with the kind of light that has already traveled so long it has forgotten its own urgency. 4 companions travel with anyone who makes a journey between the stars. They are not crew members. They are not instruments or machines. They are the conditions of the journey itself, the invisible textures of what it means to move across cosmic distance. The first is distance, which is not an obstacle but a quality, not something to be overcome but something to be passed through, the way a hand passes through still water without resistance. The second is patience, which is not a virtue here but a fact, the natural state of any motion that will take longer than a human lifetime to complete. The third is light, which is the fastest thing in the universe and still not fast enough to hurry across the space between stars without taking years and years to make the crossing. And the fourth is time, which out here is not a pressure or a deadline, but simply a dimension, as neutral and as present as any direction you might choose to move. These 4 companions are already with you, right now, in this quiet room. Distance exists between every object in your awareness. Patience is the default quality of the universe, which has been waiting billions of years without complaint. Light is arriving constantly from 100 billion galaxies without effort or intention. And time is moving alongside you, as it always has, without asking anything in return. Space, when you think of it gently, is not a terrifying place. It is not a void that threatens or a darkness that presses. It is, more than anything else, an absence of noise. Before we imagine rockets or probes or ships, before we imagine any traveler at all, space is already the most perfectly quiet environment that the universe has been able to produce. There is no air to carry sound. There is no weather to interrupt the slow drift of light between objects separated by distances so large that human words almost fail to hold them. And yet, it is not nothing. The space between stars is something. It has texture, in a very thin and gentle sense. It has particles drifting individually through the dark. It has magnetic fields threading gently through the emptiness, ancient and undisturbed. It has the faint glow of the cosmic microwave background, a leftover warmth from the earliest moments of the universe, so dim and so even that it exists everywhere, like the quietest possible hum beneath everything that has ever happened. When you breathe slowly right now, you can imagine that the breath itself carries some faint echo of that cosmic scale. The exhale, slow and easy, lasting several seconds, is not unlike the way light moves through the space between stars steadily, without hesitation, covering its distance simply by continuing. There is no secret to it. There is no technique. There is only the continuing. You are already moving, in a sense that requires no effort on your part. The Earth is moving around the Sunday. The Sun is moving through the galaxy. The galaxy is drifting through a larger structure of galaxies. Everything in the universe is already in motion, already traveling, already passing through the great distances that separate one gravitational center from another. You have always been a traveler. You simply have not needed to do anything about it. The journey that this night's words will trace begins here, in the quiet of a room that might have stars outside its window, or might have clouds, or might have the soft electric glow of a sleeping city. It does not matter. The stars are there regardless, beyond whatever is between you and the sky. They are already sending their light. They have been sending it for years, for centuries, for some of them for thousands of years, and it is still arriving, still crossing the interstellar distance, still making its patient way toward any eye or instrument that happens to be pointed in the right direction. You are that instrument, right now, open and quiet, receiving what arrives without effort. The story has already been unfolding. You are simply beginning to notice it, the way you sometimes notice a sound that must have been present for several minutes before attention finally settled on it. Everything that follows is something that was already happening before you lay down tonight. The universe was already out there, already traveling, already patient, already wrapped in its four quiet companions. You are simply allowing yourself to notice, softly, gently, at the pace of someone who knows there is no hurry. Let the distance begin. Interstellar travel means, in its simplest form, the crossing of the space between suns. It means leaving the gravitational embrace of one star, passing through the thinning edges of its influence, and entering the long, open territory that exists before any other star's presence begins to make itself felt. That territory is not short. It is not a corridor or a passage with a clear midpoint. It is the dominant condition of the galaxy itself, the default state of everything that exists between the small, warm islands of light we call stars. The word between carries real meaning here. Between two stars is not simply nothing. It is a place, or rather a condition, with its own qualities and its own quiet character. The space between stars is called the interstellar medium, and it is not perfectly empty. It contains hydrogen in very small amounts, not arranged in any useful density but present nonetheless, drifting as individual atoms across distances that separate them from their nearest neighbors, by measurements that would seem enormous on any human scale. It contains dust, grain by grain, each grain a tiny solid particle of silicate or carbon compound, separated from the next grain by distances so large that the word cloud, which astronomers use for these regions, almost seems misleading. A cloud of interstellar dust is nothing like a cloud of water vapor. It is more like a rumor of material, spread so thin across such distances that its presence is felt only in the very gentle dimming of light that passes through it over trillions of kilometers. But the interstellar medium is also threaded with magnetic fields, faint and ancient, remnants of the processes that formed and shaped the galaxy over billions of years. These fields do not create weather. They do not interact with a passing spacecraft in any way that would be noticeable to the people aboard. But they are there, woven through the emptiness, giving it a structure that pure vacuum would not have. And they carry, in their slow and patient alignment, a kind of record of the galaxy's history, a magnetic memory written in the geometry of nearly nothing. Human beings have been imagining interstellar travel for a very long time. Long before the physics of it was understood, long before the first spacecraft left Earth's surface, the idea existed. People looked at the stars and felt that they were other places, not simply lights, but destinations, and imagined what it would mean to cross the space between here and there. The idea of such a journey is older than any rocket. It is older than any telescope. It is perhaps as old as the first human mind that looked up at a night sky and understood, in some incomplete but genuine way, that those lights were very far away and that reaching them would take longer than a lifetime. What makes this imagining unusual is that it preceded the physics by so much. The understanding of how fast light travels, of how large the distances between stars actually are, of what interstellar space contains all of these, came many centuries after the basic desire to cross that space had already been imagined and expressed. The dream was ahead of the knowledge. And when the knowledge arrived, it did not diminish the dream so much as give it a more precise and humbling shape. The distances turned out to be even larger than the imagination had guessed. The speeds required turned out to be even more demanding. And the patience required turned out to be not just greater than a human lifetime, but potentially greater than many generations of human lifetimes strung together without interruption. Traveling through interstellar space is fundamentally different from any other kind of travel that takes place within the solar system. Within the solar system, you are always moving through something, always within the reach of the sun's light and gravity, always accompanied by the thin breath of solar wind, always in a gravitational relationship with something familiar. The sun remains a bright point, no matter how far out you travel within the solar system, far brighter than any other star, clearly a presence, clearly a center of warmth and influence. Even at the outermost reaches of the Oort cloud, that vast and spherical halo of icy bodies that surrounds the solar system at enormous distance, the sun is still the dominant gravitational object, still the organizing principle of everything in its neighborhood. But once you pass beyond that edge, something changes. The sun becomes, for the first time, simply a star. Not particularly bright, not clearly at the center of anything. Just one point of light among many, perhaps distinguishable for a while by its brightness relative to the others, but fading over time into the general field of stars that fills every direction. This is the moment when interstellar travel truly begins, not at the launch, not at the crossing of some arbitrary boundary, but at the moment when the familiar orientation of the solar system dissolves and what remains is only the open galaxy, equally present in every direction, offering no particular up or down or toward or away. The galaxy itself does not look crowded from the inside. This is something that requires a gentle correction of the imagination. The night sky, seen from Earth, appears populated dozens of visible stars, the gentle smear of the Milky Way across the darker parts of the sky. But this appearance is an artifact of perspective. The stars of the Milky Way are not close together. They are separated by distances of several light-years on average, each one an isolated point of warmth surrounded by an enormous territory of open interstellar space. If you shrank the Sun to the size of a single grain of fine sand, the nearest other star would be another grain of sand, located not across the room, but across a large open field. The space between them, on that scale, would be almost entirely empty. The galaxy is mostly made of its own emptiness. And yet travel through it, if it were possible, would not feel like nothing. It would feel like the texture of the interstellar medium, thin as it is, and the slow brightening and dimming of stars as they approached and receded, and the steady accumulation of distance as a felt quality rather than a numbered measurement. There is a difference between traveling through air and traveling through near nothing. In air, there is resistance. There is pressure. There is a sense of medium being displaced, of something yielding as you pass. In interstellar space, there is almost none of this. There is so little resistance that the word frictionless seems inadequate. The medium parts without parting. The spacecraft passes without displacing anything that would notice. What remains is the motion itself, clean and pure and without interruption. The velocity that carries a spacecraft away from the solar system does not fade. There is nothing to slow it down. The ship, if it were moving at a constant speed with no further propulsion, would continue at that speed indefinitely, through the interstellar medium, through the space between stars, until a gravitational encounter with another star, perhaps, or a deliberate course correction changed it. Motion, in space, is not an achievement that requires maintenance. It is simply the default condition of an object that has been set in motion, preserved without effort, carried forward through the quiet. Interstellar travel, when you think of it this way, is not really going somewhere. It is passing through distance itself. The destination, if there is one, exists at the far end of an enormous amount of passing through. And the passing through is not dead time, not waiting in an uncomfortable place for something better to arrive. It is the journey. It is what the journey is made of. The space between stars is not the price you pay to get somewhere. It is where the journey lives. You can imagine walking through a room made of glass so thin and so clear that you almost cannot feel it as you move. There is a slight sense of something yielding, of a medium accommodating your passage, but it is so subtle that after a moment you are no longer sure it was real. You simply continue through the room, and the room continues around you, and the far wall gets closer at the same steady rate regardless of whether you pay attention to it or not. That is, in a very faint and imprecise way, something like moving through the interstellar medium. The room is mostly nothing. Your motion is all you have. And the far wall, the destination star, grows slowly brighter, not because you are accelerating, but because you are continuing. Even the act of imagining the journey stretches something in the mind, opens some small interior window toward a scale that ordinary life does not usually make available. To picture the space between stars is to briefly adopt a perspective in which the distances of daily life, the length of a street, the span of a city, the width of a country become not just small, but irrelevant, folded into an invisibility so complete that they might as well not exist. The galaxy does not know about streets. It does not know about cities. It simply continues, star by star, separated by its enormous silences, patient in the way that only something truly old and truly large can be patient. The space between stars is not far away. It is, in a very real sense, surrounding everything. The nearest interstellar space begins at the edge of the solar system, which is distant on human terms, but not distant in any cosmic sense. The interstellar medium is the background condition against which the solar system exists, the way the ocean is the background condition against which an island exists. The island is real and warm and full of activity, but it is the ocean that defines the scale. A light year is not a unit of time, even though it contains the word year. It is a unit of distance, specifically, the distance that light travels in 1 year, moving at its full speed through empty space. And light moves very quickly, faster than anything else in the universe, covering enormous distances in what feels, on human terms, like no time at all. In slightly more than 8 minutes, sunlight crosses the distance from the Sun to Earth. In just over an hour, it reaches the distance of Jupiter. In 4 to 5 hours, it crosses the solar system to the vicinity of its outermost known planets. And yet, for all this speed, light takes years to reach the nearest star. More than 4 of them, in fact. The closest star to the Sun is a small red dwarf, a quiet and rather dim point of warmth, located at a distance that light itself, traveling without pause, takes more than 4 years to cross. This is not an especially large distance on galactic terms. It is, in fact, one of the shorter interstellar gaps in the galaxy. Most stars are farther from their neighbors than this. Some are separated by 5 or 6 or 10 or 20 light-years of open space. When you look up at a clear night sky, you are not seeing the stars as they are now. You are seeing them as they were, some of them as they were years ago, some decades ago, some centuries ago, a few of the dimmer ones, as they appeared thousands of years in the past. The light that enters your eyes left those stars long before it arrived. The night sky is not a view of the present moment. It is a layered record of many different moments, each star shining from a different point in the past, all arriving simultaneously at the back of the eye. You are standing inside a kind of timeline that is spread across the dome of the sky. This is not unsettling. It is, if anything, a gentle reminder that the universe is older and more continuous than any single moment, including this one. The star that sent its light 1,000 years ago was already ancient then. It continues now, in its present condition, entirely unaware that its ancient light is still traveling, still crossing the space between what it was and what any observer might be. Light is the universe's way of letting distant things know that other distant things exist, and it takes its time about it. The nearest stellar neighborhood contains a small cluster of stars that are loosely connected by their proximity, though not by any particularly close gravitational bond. The nearest is a small red star, cool and dim, orbiting at a considerable distance from a pair of stars that themselves orbit each other in a slow gravitational dance. This 2-star system at the center of the nearest stellar neighborhood, one slightly larger and slightly brighter than the Sun, one somewhat smaller and somewhat cooler, are separated from each other by roughly the distance from the Sun to one of the middle planets of our own solar system. They orbit each other over a period of several decades, a slow, celestial rotation that has been continuing for as long as the solar system has existed. The small red dwarf companion orbits much farther out, taking hundreds of thousands of years to complete a single loop around the central pair. It is the one that currently holds the title of nearest stellar neighbor, closer than its larger siblings by a small margin, measured in fractions of a light year. But on any timescale long enough to be called cosmic, these distinctions shift. Stars move. Neighbors change over millennia and millions of years. If the Sun were shrunk to the size of a grain of sand, a small sphere you could hold between a finger and thumb, the nearest star would be another grain of sand, located not across a room, but across a large open field, perhaps 3 kilometers away, depending on the specific scale. The space between them, in this model, would contain essentially nothing. A few other grains of sand, scattered randomly at similar distances, representing other stars in the local neighborhood. And between those grains, air. Just air. Not even particularly thin air, but ordinary everyday air, which would in this model be incomprehensibly more dense than the actual interstellar medium it was representing. The scale of the galaxy is harder still to hold in the mind. The Milky Way contains something in the range of 200 to 400 billion stars, spread across a disk roughly 100,000 light-years in diameter. The disk is not perfectly flat. It has a slight warp at its edges, and it is thicker toward the central region and thinner at the outer arms where the solar system currently resides. The Sun sits roughly 26,000 light-years from the center of the galaxy, which means that light from the galactic center took 26,000 years to reach Earth. Imagine the galaxy as a slow river of light. Not a river that moves quickly, not a river with rapids or cascades, but a river seen from very far above, barely moving, its light reflected from an enormous number of individual sources. The stars of the Milky Way are arranged in this slow spiral pattern, arms curling outward from the central region, each arm containing clusters and clouds of stars, separated by the usual vast interstellar distances. The spiral arms are not walls of stars. They are regions of somewhat higher density, where stars are still separated by several light-years on average, but where the overall concentration is slightly greater than in the spaces between the arms. The solar system is currently located between two of these spiral arms in a relatively quiet region of the galactic disk. This means the night sky, while beautiful, is not as dense with nearby stars as it might be from a vantage point closer to a spiral arm. It also means that the solar system has enjoyed a relatively undisturbed existence for a considerable time, without the gravitational disruptions that might come from closer stellar encounters or the higher radiation environment of the galactic center. Distance in space is not only numerical. It carries an emotional quality, or at least something that feels like one when the mind sits with it quietly. The distance between Earth and the Moon, a few 100,000 kilometers, feels within reach, small enough that it was crossed in a matter of days by spacecraft carrying people. The distance from Earth to Mars, even at closest approach, is 100 times greater, requiring months of travel. The distance to the nearest star is roughly 100 million times greater than the distance to the Moon. On that scale, the entire solar system shrinks to a dot too small to see. And yet the distance does not resist. It does not push back. It simply exists, as neutral and as patient as the light crossing it. A spacecraft moving through interstellar space at a speed comparable to the fastest spacecraft humanity has yet built would need tens of thousands of years to cross the distance to the nearest star. That is not a failure of the spacecraft. It is simply the shape of the distance. The distance is that large, and the speed is that small, and the result is the number of years required. There is no drama in this arithmetic. There is only the quiet truth of how far one thing is from another. Distance, in the interstellar sense, is not an obstacle in the way that a wall is an obstacle, or a locked door is an obstacle. It is more like a quality of the space itself, the same quality that makes the night sky beautiful, that makes stars appear small and jewel-like rather than large and overwhelming. The distance is what makes stars points of light rather than suns. It is what makes the galaxy a field of separated glow rather than a conflagration. Without the distance, the sky would not be the sky. The universe requires its enormous silences to look the way it looks. Emptiness is the default condition of the universe. Matter is the exception. Stars are islands in a sea of near nothing, and the sea is incomparably larger than the islands. Understanding this quietly does not make the stars seem less significant. It makes them seem more precious. Somehow, these warm, concentrated points of nuclear activity, surrounded on all sides by so much patient space, burning for millions and billions of years without any particular audience, without any evidence that their light is received or noticed, continuing anyway out of the pure physics of what they are. A light year, when you return to it with this context, is not just a number. It is a felt distance, even if you cannot walk it or drive it or cross it in a lifetime. It is the emotional scale at which the universe operates when it is doing what it usually does, which is holding stars in patient relationship with one another across enormous, open space, letting light carry the news between them at the fastest speed the laws of physics allow, waiting without impatience for the news to arrive. Distance does not resist travel. It defines it. The journey is made of the distance, the way a river is made of its water. You cannot have the journey without the distance, and so the distance is not the problem. The distance is the point. There are, right now, 5 human-made objects moving through or near the interstellar space beyond the influence of the Sunday. They are very small. They are very quiet. They are not going anywhere in particular. They have no destinations, no schedules, no arrivals to look forward to. They are simply moving as they have been moving for decades, carrying the accumulated velocity of their launch out into the space between stars, continuing because there is nothing to stop them. They are the farthest things human hands have ever made and released into the universe. Each of them is roughly the size of a small car. Each of them carries instruments that were designed for a solar system mission and were simply never switched off as the spacecraft continued outward past all reasonable expectations. Each of them is now so far from the Sun that the communication signals sent from Earth, traveling at the speed of light, take many hours to arrive. And the signals sent back from the spacecraft take equally long to return. The first of these travelers crossed into what is called the heliopause some years ago, becoming the first human-made object to enter the interstellar medium. The heliopause is not a wall or a sharp boundary. It is the region where the solar wind, that stream of charged particles constantly flowing outward from the Sun in all directions, becomes too weak to push against the ambient pressure of the interstellar medium. The solar wind slows, thickens, curls back on itself in a long bow shock, and eventually fades below the level at which it can maintain a distinct boundary against the interstellar material, pressing gently inward. The heliopause is the place where the Sun's influence ends and the galaxy's begins. Crossing it is not like crossing a line. It is like feeling a breeze gradually change direction, then fade, then be replaced by a different, quieter air. The particles on the other side of the heliopause are interstellar in origin. They have never been part of the solar wind, never been touched by the Sun's influence, never been within the organizational reach of this particular star. They belong to the galaxy at large. The spacecraft that crossed this boundary sent back data that confirmed the crossing through changes in the character of the particles around it, a shift in density, in temperature, in the behavior of the magnetic field. There was no fanfare, no visible landmark, no moment that felt dramatic from the outside. The spacecraft simply continued moving, and the numbers in the data slowly changed, and the scientists who were watching understood what the change meant. Now, beyond the heliopause, these small travelers are moving through the actual interstellar medium. They are sampling, with their instruments, the very material that fills the space between stars. The data they return is unlike any other data in the history of human exploration, because it comes from a place no human instrument has ever been before. The interstellar medium, measured and recorded by instruments originally intended only for the outer planets of the solar system, is now part of the scientific record of what lies beyond. Two of these spacecraft carry something unusual, not instruments exactly, but objects meant to be found. Each carries a disk, plated in gold to resist the long degradation of time, engraved and encoded with information about Earth and humanity and this particular moment in the long story of life in the universe. The disks carry sounds, ocean waves, wind, rain, the calls of animals, the music of many different human traditions, greetings spoken in many different languages. They carry images, encoded in a format that a technically capable civilization might eventually decode, showing the structure of a human body, the position of Earth in the solar system, the chemistry of life. These golden records are not messages sent with any expectation of receipt. They were included with the understanding that the probability of their being found by any other intelligence is, on any reasonable timescale, essentially zero. But they were included anyway, as a gesture, a reaching out that acknowledges the possibility of others without demanding any particular response or outcome. They are, in a sense, a form of hope expressed in physical form, pressed into gold and released into the galaxy's slow keeping. The spacecraft carrying these records will not reach the nearest star for tens of thousands of years. And they are not aimed at the nearest star. They are aimed at nothing in particular. Their trajectories are the result of gravity assist maneuvers performed decades ago, swings around the giant planets that gave them the additional velocity to escape the solar system entirely. The directions they are traveling are the directions those maneuvers happened to send them. If they encounter another star, it will be by coincidence, a matter of having happened to be moving in the right direction at the right time and right here means something that operates on scales of tens or hundreds of thousands of years. The other spacecraft in this small outward drifting fleet are quieter still. They carry instruments, but no records. Messages for no one, carrying only measurements and data back toward the Earth that made them, data that grows older and more intermittent as the distance grows. One of them has already gone silent, its power source exhausted, its instruments dark, still moving outward but no longer speaking. It is the quietest traveler, a piece of human engineering, moving through the interstellar medium in complete silence, carrying the memory of its mission, like an object carries the memory of the hands that shaped it. All 5 of these small machines share certain qualities that make them, in some abstract and gentle way, remarkable. They have no urgency. They are not racing to a destination. They are not trying to arrive anywhere by any particular time. They are simply moving at speeds that are fast by human standards and slow by interstellar standards, through a space so empty and so quiet that the concept of hurrying would be meaningless. They have been traveling for decades. They will travel for millennia. Eventually, long after any trace of the civilization that made them has been absorbed into whatever comes next, they will still be moving through the galaxy, their gold records still intact, their metal bodies largely unchanged by the thin medium through which they drift. They are not the future of interstellar travel. They were not designed to be. They were designed for the outer planets, and the outer planets were what they studied, and the interstellar mission they eventually became was not planned, but simply allowed, an extension of their original motion beyond all original expectations. They drifted outward, not because anyone commanded them to, but because the physics of their trajectories carried them there, and no one turned them around, and the interstellar medium was waiting. Motion without destination is still a form of travel. The spacecraft do not need to be going somewhere specific to be going. They are covering distance. They are crossing the interstellar medium particle by particle, magnetic field line by magnetic field line, moving through a space that no other human-made object has ever moved through. The fact that no destination waits for them does not diminish the journey. It simply changes what kind of journey it is. It makes it more like drifting than like arriving, a long, slow movement through stillness, a continuation of motion that began with the press of a launch pad and will end only when something in the universe finally interrupts it. Think of them sometimes, out there in the dark, each one alone, each one carrying its small collection of instruments and memories, each one moving through the interstellar medium at a speed that covers roughly 500,000 kilometers in a single day, and still takes tens of thousands of years to cross even a fraction of the distance to the nearest star. They are patient in the way that only objects without consciousness can be patient completely, utterly, without any relationship to impatience at all. They do not know they are traveling. They do not know they are far from home. They simply move, as objects in space simply move, continuing, because continuing is what they do. They are already outside human time in a practical sense. The people who built them are no longer young. Many of the people who first tracked their signals have already lived out their lives. The spacecraft continue. The signals where they still exist continue to arrive after their long journey at the speed of light. And the small machines drift outward, slow drifting memories of a particular civilization at a particular moment, released into the keeping of the galaxy without any expectation of return. Beyond the 5 small travelers that are actually moving through the space beyond the solar system, there are ships that have never been built, that exist only in equations and proposals, and the quiet imagination of people who have spent time thinking carefully about what interstellar travel might actually require. These imagined ships are not fantasies, exactly. They are not pure fiction. They are engineering ideas that take the real physics of the universe seriously and ask what a ship would have to be if it were to cross the distance between stars in a time frame that a human civilization might find meaningful. The simplest idea, in some ways, is also the oldest. A generation ship is a craft so large and so self-sufficient that it does not need to arrive at its destination within any single human lifetime. Instead, it carries not just a crew, but a community, people who will live and work and have children aboard the ship, whose children will do the same, and whose grandchildren and great-grandchildren will be the ones to finally arrive, many generations after the original crew departed. The ship is not transport. It is home. It is a contained world, a closed ecology, a civilization in miniature, moving slowly through the interstellar dark, while life inside it continues in all the ordinary ways that life continues: meals and sleep and work and conversation and the small daily texture of being alive. This idea requires a ship of considerable size. It requires closed-loop life support systems that can maintain breathable air and drinkable water and growable food across centuries of operation without resupply. It requires a community large enough to remain genetically and socially healthy across many generations, and a culture with enough continuity and purpose to maintain the mission as a meaningful enterprise even to people who were born aboard the ship and will die aboard the ship without ever knowing any other kind of sky. The people who arrive at the destination will be the descendants of the people who departed. The mission is inherited, passed down like a family story or a long promise. There is something very quiet about this idea when you sit with it gently. A generation ship is, in a way, the most honest possible form of interstellar travel. It does not pretend that the distance is small. It does not compress or deny the time required. It simply says, the distance is what it is, the time is what it is, and life can continue within the time as it always continues, one generation at a time, one day at a time, finding meaning in the immediate and the local, even while the larger journey proceeds at its own patient pace. A different kind of imagined ship attempts a different relationship with time. Sleeper ships, ships designed to carry their passengers in some form of extended, suspended animation, try to fold time inward to make the centuries of travel invisible to the people experiencing them. The passengers would be cooled, or chemically maintained, or held in some other form of reduced biological activity, and would wake on the far side of the journey in a star system different from the one in which they fell asleep. For them, the crossing would feel like a night's sleep stretched across multiple human generations. The ship would travel for them. The time would pass without their experience of it, and arrival would follow departure as naturally as morning follows the closing of eyes. This approach, technically challenging in ways that have not yet been resolved, offers a kind of time travel in a gentle direction, not toward the past, but simply through the future, skipping the long middle section of a journey that biology would not easily accommodate. The passengers would arrive younger, in subjective experience, than the generations of people on Earth who had lived and died during the crossing. They would find themselves in a future that belongs to them, and yet has been shaped by a civilization they are no longer quite continuous with. Home, for them, would be a place that has changed in ways they did not witness. Then there are ships that use no fuel at all, or rather, ships that use the fuel of light itself. A light sail, sometimes called a solar sail, is a sheet of material so thin that the pressure of photons, the particles that make up light, is sufficient to push it. Within the solar system, sunlight itself provides this pressure. As you move farther from the sun, the pressure of sunlight decreases with distance, becoming less and less effective. But a different kind of light sail, proposed for interstellar travel, would use not sunlight, but a powerful laser beam aimed from within the solar system, pushing a very small and very thin sail across the interstellar distance. The laser would provide a long and gentle push, not the explosive acceleration of a chemical rocket, but a sustained, steady pressure maintained over months or years, building velocity slowly and patiently until the sail and its small payload were moving at a significant fraction of the speed of light. The light sail is an elegant idea because it requires no fuel aboard the craft itself. The craft is pushed, not driven. The energy source remains behind in the solar system, and the craft simply receives the push and continues. Once the laser beam can no longer reach the craft, either because the distance has become too great or because the angle has changed, the sail continues on its own inertia, moving at whatever speed it has accumulated through the interstellar medium toward whatever destination the laser was pointed. Imagined ships, powered by other means, include vessels that carry miniature versions of the nuclear fusion reactions that power stars. A fusion drive would extract energy from the combination of light atomic nuclei, hydrogen isotopes, typically, and use the energy released to propel the ship. This is how stars shine, and if a ship could do what a star does in a controlled and directed way, it would have access to a very large amount of energy relative to the mass of fuel it carried. The engineering challenges are considerable, and fusion propulsion for spacecraft remains in the realm of the imagined rather than the realized. But the physics does not prohibit it. The principles are real, the energy is real, and the possibility exists at the edge of what engineering might someday achieve. At the further reaches of imagined propulsion are ideas involving antimatter material, identical to ordinary matter, but with reversed charge properties, which annihilates in a burst of pure energy on contact with ordinary matter. An antimatter drive would, in principle, extract the maximum possible energy from the minimum possible mass, making very high velocities conceivable without requiring enormous fuel loads. The challenges of creating antimatter in useful quantities and then storing it without touching any ordinary matter are extremely significant. But again, the physics is real. The obstacle is engineering, not principle. And then, at the very edge of what current physics can even describe, there are concepts that involve not moving through space faster, but reshaping space itself. A craft moving within a bubble of compressed and expanded space-time, space contracted ahead of it, space stretched behind it, might theoretically cross interstellar distances in a fraction of the time that ordinary motion would require, not by exceeding the speed of light, but by exploiting the geometry of space-time itself. These ideas are consistent with the mathematics of general relativity, though they require forms of matter and energy that have not yet been observed or created, and may not be possible in any practical sense. They exist at the boundary between physics and philosophy, between what the equations permit and what the universe will actually allow. None of these ships are urgent. None of them need to be built today or tomorrow. They are possibilities resting at the edge of physics, sketched in equations and proposals, waiting for the level of civilization and the depth of will that might someday choose to pursue them. They are thought experiments made visible, not blueprints exactly, not science fiction exactly, but something in between, real enough to be taken seriously and distant enough to be held gently, without the pressure of immediate implementation. The value of these imagined ships is not in any particular design, but in what they represent, the continued human act of looking at an enormous distance and asking not whether it can be crossed, but how. The question itself is a kind of travel, a reaching of the imagination across the same space that light crosses, slower but just as continuous, just as patient, following the same patient impulse that led people to look at the stars long before they understood what the stars were. All these ships remain in the quiet notebook of possibility. They drift there like sketches on a page that has not been printed yet present, real in their way, waiting without urgency for the right conditions to become something more substantial. And in the meantime, the 5 small travelers that do exist continue their motion outward, unaware of the imagined companions being designed for journeys they will never take. There is a moment in the imagined departure when the sun begins to look different. Not dramatically, not all at once, but gradually, over days and weeks of outward motion, the star that has always been the organizing center of everything in experience begins to change character. It remains bright for a long time, distinctly brighter than any other star, clearly the dominant light source in whatever direction the traveler faces. But it is shrinking, slowly and continuously, with a patience that matches the patience of the journey itself. At the distance of Mars, the sun already appears smaller than it does from Earth, still overwhelmingly bright, still the clear source of all warmth and light, but visibly reduced. At the distance of Jupiter, the reduction is more pronounced. The sun's disk is barely a quarter of what it appears from Earth, and the level of light it provides has dropped considerably. At Saturn's distance, the sun is a bright star in a dark sky, identifiable, clearly distinct, but no longer the warm presence it is from closer in. The planets of the outer solar system receive so little sunlight that their surfaces are in a kind of permanent, gentle dusk, nothing like the bright daylight of the inner planets. Beyond the outermost planets, the sun continues to shrink and dim. By the time the heliopause is approached, the boundary of solar influence, the sun has become simply the brightest star in the sky. Not overwhelmingly so. The difference between it and the next brightest stars has narrowed considerably. It remains distinctive, remaining recognizable as a particular star to someone who knew where to look, but it has lost the quality of dominance that it carries for all of human experience on Earth. It is now just another star, slightly brighter than most, in a field of other stars that extends in every direction. Once that boundary is crossed, the the sun fades further still. It remains visible, a bright point of light behind the traveler, but the sky ahead and around is now a field of stars of relatively similar brightness, and the sun is simply one of them. The constellations that were familiar from Earth have begun to shift. The patterns of the night sky, as seen from Earth, those ancient arrangements of coincidentally aligned stars that cultures across history have named and storied, are a product of the particular vantage point of Earth. Move far enough away from that vantage point, and the patterns begin to change. Stars that appeared close together from Earth are actually at very different distances, and as the traveler moves, the parallax shifts, and the constellation shapes slowly distort. This change in the appearance of the sky is not sudden. It is gradual, accumulating over many years of travel. But eventually, at interstellar distances, the familiar night sky of Earth is gone. The constellations that named bears and hunters and rivers and crowns, which were really just the accidents of Earth's position in the galaxy, have dissolved into a different arrangement of stars, equally beautiful, equally arbitrary. The sky is still full of stars. There are still patterns that a human eye would find and name, but they are not the patterns of home. Home, at interstellar distances, becomes a reference rather than a location. There is a star behind the traveler, slightly brighter than average, in the direction of what was once called the constellation Centaurus, as seen from Earth, but now appears from a completely different angle. That star is the Sunday. Earth is around it, invisible at this distance, far too small and far too dark to be detected by any instrument the traveler might carry. The entire civilization, everything built and written and spoken and imagined across all of human history, exists within a space that can be covered by holding up a thumbnail and squinting. Compressed to a theoretical point of light, not separately distinguishable from the star it orbits. This could feel like loss. But it can also feel like perspective, the same perspective that any great distance provides, the understanding that things look different from far away, that scale changes what is visible and what is important, and that the universe is large enough to contain both the immensity of the human world from within it and the smallness of the human world from outside it. Both are true. The choice of which to feel is a matter of framing, not of fact. There is no horizon in interstellar space. This is something the imagination can take a moment to process. On Earth, the horizon is a constant presence, a line where the surface curves away below the limit of vision, a boundary between near and far that organizes the view and provides a sense of ground. In space, there is no surface, and no curve, and no ground. In every direction, the view extends to the same apparent distance, the distance at which stars are visible, and there is no edge, no wall, no place where it stops. It continues in all directions, equally, without exception. This is what the word omnidirectional means in practice. Everywhere is out there. Every direction leads to more space, more distance, more stars at enormous removes. The familiar orientation of up and down dissolves without gravity to enforce it. Forward and backward are only meaningful in relation to the direction of travel. The traveler in interstellar space is surrounded on all sides by the same gentle field of stars, the same thin interstellar medium, the same ancient and undisturbed quiet. Above, if above means anything at all, in this context, the disk of the Milky Way lies flat across the sky, a soft band of concentrated starlight marking the plane of the galaxy. Below, the disk recedes in the same direction. Around, the disk curves away in both directions, and in the perpendicular directions, the disk thins out, and the extragalactic universe becomes more visible to other galaxies, faint smudges of light at enormous distances, each one containing hundreds of billions of stars, each one surrounded by its own vast empty space. The Milky Way, seen from within the plane of the disk, appears as a band rather than a face-on spiral, because the galaxy is seen edge-on from Earth's position. From interstellar space, the band is still present, still the most prominent feature of the sky in terms of light concentration. It is a constant presence, a soft backdrop of accumulated starlight that marks the galaxy's disk in every direction along its plane. And everywhere, in every direction that the traveler might turn, there is the absence of weather. There is no rain in interstellar space, no wind, no cloud, no temperature variation caused by the presence or absence of sunlight on a nearby surface. The temperature of the interstellar medium itself is extraordinarily cold within a few degrees of absolute zero in most regions. But the spacecraft and its occupants would be insulated from this by their own heat generation, and the temperature of the space around them would not be experienced as cold so much as simply not warm, a neutral condition in which the usual relationship between outside temperature and inside experience does not apply. In every direction the traveler looks, there is a star that is another sun, another possible center of warmth and gravity and planetary systems. The nearest are years of light away. The farthest visible ones are thousands and millions of years away, their light ancient, their current conditions unknown. But all of them are present in the sky, each one a pinpoint of calm nuclear fire, each one surrounded by its own silence, each one the possible center of a story that may or may not involve any kind of awareness looking back. The sun, behind the traveler, is one of them now. One point of light among many, carrying no special marking, not distinguished by the fact that it has a small rocky planet in close orbit on which the entire history of biological life on Earth has unfolded. From far enough away, it is simply a G-type star, slightly warm yellow in color, of average size and average brightness, located toward the outer edges of a spiral galaxy in a quiet neighborhood of the interstellar medium. Every direction in interstellar space eventually becomes forward. There is no particular back. There is the direction of travel, and there are all the other directions, and any one of them could become the direction of travel with a change of course. Home is the direction where a particular star sits, slightly brighter than average, but home is also just a direction now, a bearing in the sky, not a place underfoot. The traveler carries home as a reference point, the way a navigator carries a compass reading, knowing which way it points but no longer being there. Aboard a ship moving through interstellar space, time passes as it always passes meals, rest cycles, work periods, the small daily texture of routine that organizes experience, regardless of location. The clock aboard the ship ticks at a rate indistinguishable from any clock on Earth, experienced by the people aboard as the normal flow of minutes and hours and days. Time is not felt differently by a traveler in interstellar space, except in the ways that any long journey eventually changes the relationship with time, a certain loosening of urgency, a longer perspective on the ordinary, a reduced investment in the particular moment, as opposed to the accumulating experience of the journey itself. But time on an interstellar journey is also genuinely different in a way that goes beyond felt experience. The physics of motion, at speeds approaching a significant fraction of the speed of light, introduces a real and measurable difference between time as experienced by the traveler and time as experienced by someone who remains behind. This effect, called time dilation, is not a trick of perception or a psychological adjustment. It is a physical consequence of the structure of spacetime, a real difference in the rate at which clocks tick depending on the speed at which they are moving. The effect is small at ordinary speeds. A jet aircraft, a fast car, even the fastest spacecraft currently in existence, None of these move quickly enough for time dilation to be more than a few thousandths of a second over a lifetime of travel. But as a ship approaches a significant fraction of the speed of light, say a quarter or half of light speed, the effect begins to accumulate in ways that become meaningful over the length of an interstellar journey. A ship traveling at a significant fraction of light speed for the time required to cross several light years would find that less time has passed for the people aboard than for the people on Earth. Not dramatically less in the early scenarios, but measurably so. And at speeds closer to light speed, if they were ever achievable, the difference would be profound. For a traveler aboard a ship moving at 90% of the speed of light, a journey that takes 10 years by Earth's clocks would feel like somewhat less than 5 years aboard the ship. At 99% of light speed, the compression is much more extreme. And at speeds approaching even closer to light speed, still theoretical, still far beyond current capabilities, the compression becomes so great that a traveler could cross the galaxy in a subjective experience of years, while thousands of years passed on Earth. This does not mean the traveler is getting something for nothing. Energy still has to come from somewhere, and the energy required to accelerate a large mass to a significant fraction of light speed is enormous, far beyond anything currently achievable. The time dilation is real, but so is the cost of achieving the speeds that produce it. The universe keeps its accounts carefully. The quieter aspect of this time difference, for an interstellar traveler moving at any realistically achievable speed well below the speed of light, is the communication delay. A message sent from the ship toward Earth, or from Earth toward the ship, travels at the speed of light. This means that as the distance between ship and Earth grows, the delay between sending and receiving grows with it. At 1 light-year of distance, a message takes a year to arrive, and a year for the reply to return, a 2-year gap between a question and its answer. At 5 light-years, the round-trip delay is 10 years. At the distance of the nearest star, a conversation becomes something closer to an exchange of letters sent between generations, each message a capsule of a particular moment, arriving years later to a recipient who has lived through all the time in between. This communication delay changes the psychological relationship with home in a way that is difficult to anticipate from within the normal experience of instant communication. On Earth, news from across the world arrives in seconds. People in close relationships can exchange words at any moment of the day or night, separated by any distance, without meaningful delay. The interstellar traveler loses this. The delay is not a technical failure, it is a physical law, a consequence of the same speed of light that governs all other electromagnetic signals. There is no way around it. Messages are sent, and then the sender waits, months or years, for the light carrying the reply to cross the widening space. This enforced waiting changes the sense of urgency that normally accompanies communication. Questions lose their immediate character. News from home becomes, by the time it arrives, historical rather than current. The traveler learns to exist in a longer now, a present moment that is defined more by the immediate environment of the ship and the immediate experience of the journey than by any connection to the distant and increasingly historical Earth. Time becomes something that the traveler moves alongside, rather than through a companion at the pace of the journey, rather than a pressure from outside. There is a certain peace in this when approached without resistance. The universe is not synchronized. It does not operate on any single clock. Every point in space has its own experience of time, shaped by its own velocity and its own gravitational environment, and the interstellar traveler simply inhabits one of those points, one of those particular temporal perspectives, no more or less valid than any other. Earth is not the standard. The ship is not the deviation. Both are real. Both are experiencing time correctly according to the physics they inhabit. And the difference between them is simply a consequence of where they are and how they are moving. Deep in the long passage between stars, time accumulates quietly. Days become weeks, become months, become years. The ship continues. The crew, or the passengers, or the community, depending on which imagined ship is in motion, continues with it, living their lives in the time that is available to them, in the now that surrounds them, in the specific present of a small, warm world moving through a cold and very quiet universe. Eventually, the concept of now becomes less connected to any external reference. There is no news to receive that is current. All news from Earth is historical by the time it arrives. There is no schedule imposed by any authority outside the ship. There is only the schedule the travelers create for themselves, the rhythm of their own days, the passage of time as they measure it in the most immediate and personal way, by the accumulation of experience, by the changing of seasons they have invented for themselves, by the slow aging of their bodies and the slow growth of the children born aboard. Time becomes a companion on an interstellar journey in a way it rarely is in ordinary life. Ordinary life is often organized around resistance to time, trying to do things faster, to accomplish more in less of it, to arrest its passage in photographs and recordings. In interstellar space, resistance to time is not available. The time is what it is. The journey takes what it takes. The travelers have nothing to do but inhabit their time fully, allow it to be what it is, and continue moving through it as they move through the space that surrounds them steadily, without hurry, without the option of hurry, which perhaps makes the traveling easier in ways that are hard to quantify. The interstellar medium is not nothing, but it is very close to nothing by any ordinary measure. In the space between stars, matter exists in quantities so small and so dispersed that the word thin does not quite capture the condition. The interstellar medium in the region of space near the solar system contains, on average, roughly 1 atom per cubic centimeter. 1 atom in a space the size of a small sugar cube. Compare this to the air in a room, which contains roughly 10,000 trillion atoms in the same volume, and the character of the interstellar medium begins to be felt as a quantity. These atoms are mostly hydrogen, the simplest and most abundant element in the universe, a single proton and a single electron in their most fundamental configuration. Some of the hydrogen exists as individual atoms. Some exists as molecular hydrogen, 2 atoms bonded together in the simplest possible chemical relationship. There is also a small amount of helium, the second most abundant element, and trace quantities of heavier atoms, carbon, oxygen, nitrogen, iron, each one present in vanishingly small concentrations, each one a reminder that stars have lived and died in this region of the galaxy over billions of years, seeding the interstellar medium with the products of their nuclear reactions. The dust grains of the interstellar medium are separated by distances that would seem vast even by the standards of astronomical discussion. A typical dust grain in a diffuse interstellar cloud, and diffuse is the right word, because these clouds are far less dense than any cloud encountered on Earth, might be separated from its nearest neighbor by distances measured in centimeters if the grains were the size of specks of ordinary dust. But they are not, of course, in a room. They are distributed through volumes of space measured in light years, which means the actual separation is measured in enormous fractions of light years, or in other words, enormous fractions of trillions of kilometers. A spacecraft moving through this medium does not feel it as resistance. The particles it encounters are too sparse and too small to create any meaningful drag. A single grain of interstellar dust encountered by a fast-moving spacecraft would be an impact too small to measure, with most instruments a tiny pebble of material, perhaps a millionth of a meter across. struck at high velocity but carrying almost no mass. Over very long periods of interstellar travel, at very high speeds, the accumulated effect of many such impacts might become relevant, and spacecraft designs for interstellar travel take this into account with shielding at the leading surface. But in the early phases of an interstellar journey, at the speeds currently achievable, the medium is effectively transparent. The silence of the interstellar medium is absolute in the sense that matters most. There is no medium for sound to travel through. Sound is a pressure wave, a pattern of compressions and expansions in a medium: air, water, solid material. In the interstellar medium, the density of material is too low to support sound waves of any kind. A supernova could explode nearby, releasing more energy in a few seconds than the sun will release in its entire lifetime, and the sound of it, if sound it could be called, would never propagate to any distance. Only the electromagnetic radiation, the light and radio waves and X-rays, would travel outward. The shock wave of compressed interstellar material would travel at the speed of sound in that medium very fast, but still far slower than light. But it would be a wave of material, not truly sound in any way that would be audible. The quiet of interstellar space is therefore not simply the absence of loud sounds. It is the absence of the physical possibility of sound. A traveler in interstellar space who floated outside a spacecraft, setting aside the other challenges of such a situation, would hear absolutely nothing regardless of what was happening around them. No hum of engines, no vibration of structure, no ambient noise from the medium itself. The sound of the universe in interstellar space is a theoretical zero. What remains, in this physical silence, is electromagnetic information. Radio waves from distant civilizations, if any exist and are broadcasting. Cosmic rays, high-energy particles moving at nearly the speed of light, remnants of ancient violent events in the galaxy. The cosmic microwave background radiation, the faint afterglow of the earliest moments of the universe, present everywhere with extraordinary uniformity, a kind of whispered constant across all of space and time. Starlight in all its forms, visible, infrared, ultraviolet, arriving from every direction after years and centuries of travel. This electromagnetic richness is not something the human senses can perceive directly. It requires instruments to detect and interpret. But it is present, threading through the interstellar medium in every direction, an invisible traffic of information crossing the galaxy at the speed of light, carrying news of events both ancient and ongoing, from sources both near and unimaginably distant. The interstellar medium is quiet to the ear and alive to the electromagnetic sense, a constant exchange of signals that have been in transit for periods ranging from years to billions of years. The magnetic fields of the interstellar medium, those ancient thread-like structures woven through the emptiness, are weak but present. They are far too weak to be felt by any instrument as a direct mechanical force. But they influence the paths of charged particles moving through the medium, bending the trajectories of cosmic rays, organizing the behavior of charged interstellar atoms, maintaining a faint structural coherence in what would otherwise be purely random distribution of material. These fields are the memory of past events, supernova explosions, stellar winds, galactic rotation preserved in the alignment of charged particles across distances of many light years, patient and ancient. The interstellar medium, in different regions of the galaxy, takes on different characters. In the denser regions near star-forming clouds, the density of material is higher and the temperature is lower, and the clouds are thick enough to block visible light from stars behind them. Dark nebulae, patches of sky where the stars seem absent because their light has been absorbed by interstellar dust before it reaches any observer. In the hot regions near young and energetic stars, the interstellar medium is heated and ionized, glowing with its own light as energetic photons from nearby stars strip electrons from hydrogen atoms. And those electrons eventually recombine, releasing photons of visible light in the process. These are the emission nebulae, those glowing regions of space that appear in images as colored clouds. But in the quiet neighborhood where the solar system currently resides, the interstellar medium is in a calmer state, sometimes called the local bubble, a region of relatively hot, low-density interstellar medium that appears to have been cleared and heated by ancient supernova explosions, leaving behind a more tenuous environment than many other parts of the galaxy. It is a fortunate neighborhood, in a way not especially active, not especially dense, offering the solar system a calm passage through the galaxy for many millions of years without significant disruption from the surrounding medium. Through this quiet, the 5 small travelers move. Through this quiet, imagined ships drift in the space where thinking has put them. Through this quiet, light carries all the news there is to carry, at the fastest speed available, patient and unhurried, and utterly indifferent to whether it is received. Absence is the dominant quality here. But it is not an uncomfortable absence. It is not the absence of something needed, the absence of air in a sealed room or water in a desert. It is the absence of interference, of noise, of competition, of the accumulated pressure of things. It is a softness rather than a void. The interstellar medium is not empty in the way a drained cup is empty, waiting to be filled, incomplete without its contents. It is complete as it is. The sparseness is not a deficiency, but a character. And through that sparseness, slowly and without fanfare, the galaxy's slow exchange of materials and energy continues, stars forming in the denser clouds, burning for millions or billions of years. Seeding the interstellar medium with new elements when they die, that material slowly drifting, slowly accumulating into new clouds, new collapse, new stars. The interstellar medium is not static. It is part of the great long cycle of stellar formation and death, participating without urgency, moving without hurry, maintaining its near-nothingness as the background against which the galaxy's more concentrated events unfold. Arrival at the end of an interstellar journey would not feel like a sudden event. It would not be a moment, sharply defined, where 1 second the traveler was between the stars and the next second they had arrived. It would be a long, gradual process of resolution, a slow sharpening of something that had been a point of light into something with shape, with structure, with the qualities of a real and present place. From interstellar distance, even the nearest stars appear as points. No telescope carried by current spacecraft, and no telescope likely to be carried by any near-future spacecraft, could resolve a star into a visible disk at a distance of several light-years. The star is simply a point of light, brighter than the others in that direction, but without dimension. It is a destination in the way that a city at the far end of a long, dark road is a destination visible as a glow on the horizon long before any individual detail can be made out, recognizable by its general presence rather than by any specific feature. As the journey approaches its final stages, and final here means the last decades or centuries of a journey that has lasted centuries or millennia, the destination star begins to show subtle changes. Its brightness increases, slowly at first, then more noticeably as the remaining distance closes. What was one bright point among many becomes the one undeniably brightest object in the sky ahead, the way a lighthouse grows from a suggestion to a clear and specific presence as a ship approaches through fog. If the destination star has planets, and the majority of stars, the evidence now strongly suggests, have some kind of planetary system, those planets would become detectable through their gravitational influence on the star long before they became visible as anything other than a faint variation in the star's light. The careful measurement of the star's light, the precise tracking of its motion, would begin to reveal the presence of planetary companions, the slight wobbles and dimmings that betray objects in orbit around a central light source. From years out, a careful navigator might construct a rough model of the planetary system, the number of objects, their approximate sizes and orbital periods, the character of the system as a whole. This kind of approach, slow, careful, gathering information continuously over a long period, rather than arriving suddenly and having to take stock in the moment, is perhaps the most appropriate way to arrive at a new star system. It gives time for adjustment, for the gradual updating of expectations, for the slow incorporation of new information into a picture that was previously entirely hypothetical. The travelers have had years or decades of increasing data to prepare them for what they are approaching. Arrival is the end of a long process of preparation that has been ongoing since the star was still a point of light. The contrast between a flyby and an arrival is worth holding gently in mind. A flyby is what the 5 small travelers currently moving outward from the solar system will experience if they happen to pass near another star system tens of thousands of years from now, a brief passage. Covering years of distance in a relatively short time relative to the journey, close enough perhaps to gather some scientific data, but too fast to slow down, too committed to its outward motion to linger. The destination is not really a destination for a flyby, it is a point in a continuous trajectory, a moment of closest approach in a journey that continues beyond it. Arrival is different. Arrival requires slowing down, which requires fuel or some other mechanism for deceleration. A spacecraft that has been traveling at interstellar speeds cannot simply stop at its destination. It must expend as much energy decelerating as it expended accelerating, which doubles the energy requirement of any interstellar mission that intends to arrive rather than simply pass through. This is one of the significant engineering challenges of any crewed interstellar mission, not just getting up to speed, but shedding that speed again at the far end, against the only available gravitational assistance of the destination star system. But if the deceleration is achieved, arrival unfolds in the most patient way possible. The destination star grows from a bright point to a visible disk over a period of weeks or months as the spacecraft slows and approaches. The planets, previously detectable only through indirect means, gradually become visible as their own reflected light separates from the stellar background. The system resolves itself from an abstract collection of data into a visible, spatial reality. There is the star, there is the larger planet in the outer system, there is a smaller world in the inner zone. There are the rings of dust that might indicate the presence of a planetary disk still forming, or one that has finished forming and left its debris behind. This resolution does not happen quickly. It is a long, slow sharpening, like watching a photograph develop from nothing into full clarity over an extended period. Each day, the picture is slightly more detailed than the previous day. Each week, new features become distinguishable that were previously blended into the overall glow. The travelers are not passive in this process. They are actively measuring, calculating, updating their models, discussing what they see and what it implies, making decisions about which parts of the system to approach more closely and which to observe from a safe distance. Worlds at close range, never visited before, reveal themselves in layers. The first layer is light, the character of the starlight reflected from the planetary surface, which can reveal something about the surface composition and the presence or absence of an atmosphere. The second layer is structure, the shapes of clouds, the variations in color and reflectivity across the surface, the presence of polar ice or large bodies of liquid or volcanic activity. The third layer is the atmosphere itself, its composition and depth, measurable through the way it scatters and absorbs light. And beneath all of these is the surface, which would require close approach, and perhaps landing or atmospheric sampling to understand directly. None of this happens in a moment. The layers reveal themselves over time, each one requiring a different kind of observation, a different distance, a different instrument. Arrival is not a threshold crossed, but a gradient descended. From the initial faint recognition of a destination, through the gradual resolution of its character, to the final close approach, where the details are clear and the decision about what to do next can be made on the basis of real information rather than speculation. And beyond the destination, even after arrival is complete, motion continues. The galaxy does not stop. The destination star is itself moving through the galaxy, as all stars move, at its own velocity and on its own trajectory. The travelers, having arrived, have simply joined the motion of the destination system, its orbit around the galactic center, its slow drift through the interstellar medium, its relationship with neighboring stars. They have not reached an ending point. They have reached a new position in an ongoing motion, a new vantage point from which the galaxy continues to present itself in all its patient, unhurried vastness. The Milky Way is rotating. Not quickly, not with any urgency, but continuously and at a scale that dwarfs any other rotation familiar from ordinary experience. The stars in the disk of the galaxy orbit the galactic center over periods measured in hundreds of millions of years. The Sun, located roughly 26,000 light-years from the center, completes one orbit in approximately 225 million years, a period sometimes called the galactic year or cosmic year, a single turn of the galaxy around its own center. In the course of that one galactic year, the Sun has moved through a neighborhood of space that changes slowly but continuously. Stars that are currently neighboring the Sun have been in its general vicinity for only a small fraction of the Sun's total lifetime. Over millions of years, the stellar neighborhood shifts. Some stars move closer, some move farther away. The general density of stars around the solar system changes as it passes through different regions of the galactic disk. The constellations, as seen from Earth, are not permanent. They are the snapshot of a particular moment in the galaxy's long rotation, a configuration that will persist for human timescales, but will slowly change over millions of years as each star moves on its own trajectory through the galactic disk. Some stars will pass closer to the solar system in the future than any star has been in the recent past. Not close enough to cause significant gravitational disruption in the ordinary course of events, but close enough to be easily visible in the night sky, possibly close enough to influence the long-period comets of the Oort cloud, nudging some of them onto new paths that might eventually bring them into the inner solar system. These stellar passages are slow and gentle by cosmic standards, the approaching star detectable decades before its closest approach, its influence felt in the slight perturbation of the outermost members of the solar system over thousands of years. The galactic center itself is a different environment from the quiet outer disk where the solar system currently resides. Near the center of the galaxy, stars are far more densely packed. The interstellar medium is more active and more turbulent. And at the very center sits an enormous concentration of mass in a small region of space, a supermassive object, the gravitational anchor of the entire galaxy, around which the billion-year orbits of all the galaxy's stars ultimately curve. The stars near this central object move quickly and elliptically, responding to the gravitational environment of an extremely dense region. The solar system, in its position toward the outer edge of the galactic disk, is insulated from this central activity. The journey from here to the galactic center, even at the speed of light, would take 26,000 years. At any achievable spacecraft speed, it would take incomparably longer. The center is, in practical terms, as inaccessible as any other part of the galaxy, perhaps more so, given that the environment near the center is less hospitable than the quiet outer disk. But every star in the galaxy is already a traveler. This is not a metaphor. Every star orbits the galactic center, moving at its own velocity, following its own path through the galactic disk, influenced by the combined gravity of all the other stars and the dark matter that pervades the galaxy. The Sun moves at roughly 230 kilometers per second around the galactic center, a speed that seems very fast in human terms, but takes 225 million years to complete a single orbit. Every nearby star is also moving at its own speed and in its own direction, and the relative motions of stars in the solar neighborhood produce the slow drift of stellar positions over millions of years. This universal motion means that there is no fixed map of the galaxy, no permanent arrangement of stars that will persist indefinitely. The galaxy is not a static structure. It is a dynamic, slowly evolving system in which every component is in motion relative to every other component. Stars form in dense molecular clouds, live out their lives over millions or billions of years, and die, sometimes gently, releasing their outer layers into the interstellar medium, sometimes violently, in a rapid collapse that produces a neutron star or a black hole and sends a shockwave through the surrounding medium. The material of dead stars seeds the next generation of molecular clouds, which collapses to form the next generation of stars, which live out their lives and die continuously over the galaxy's long lifetime. The galaxy is approximately 10 billion years old, roughly twice the age of the solar system. In that time, it has gone through many cycles of star formation, stellar evolution, and stellar death. The elements in our bodies, the carbon, oxygen, nitrogen, iron, and all the others, were processed through the interiors of stars that lived and died long before the solar system formed. We are, in a very physical sense, products of the galaxy's history, assembled from materials that have been through stellar interiors and interstellar clouds, and the slow collapse of those clouds into new stars over billions of years. This long timescale makes any individual interstellar journey seem very short, even the ones that take thousands or millions of years. The galaxy has been doing its work for 10 billion years and will continue for many billions more by most current estimates. Stars will continue forming for a long time yet. The interstellar medium will continue cycling between stars and clouds for a long time yet. The galactic disk will continue its slow rotation for a long time yet. In this context, the 5 small spacecraft currently drifting outward from the solar system are not just human artifacts. They are also participants in the galaxy's motion, tiny objects, barely distinguishable from interstellar dust in terms of their gravitational influence, but moving through the same medium and on the same general trajectory as everything else in the galactic disk. They will orbit the galaxy over tens of millions of years, along with all the stars and dust and dark matter that make up the disk. They will be scattered, eventually, by gravitational encounters, deflected from their current trajectories by the cumulative small influences of passing stars and molecular clouds. Their paths will diverge from their current trajectories over geological timescales. But they will continue, as everything in the galaxy continues, subject to the same slow forces that govern everything from the smallest grain of dust to the largest star. There is a quiet democracy in this understanding, the recognition that everything in the galaxy is subject to the same forces, moving on timescales that dwarf any individual story, but that collectively make up the ongoing story of the universe itself. A star is not more important than a grain of dust in this sense. Both are participants. Both are products of the galaxy's history. Both are moving through the same vast medium toward futures that neither knows. Motion is universal. Travel is not an exception or an ambition. It is the default condition of everything that exists in a universe where gravity shapes the paths of all material objects and everything is continuously moving relative to everything else. An interstellar journey is simply a particularly conscious version of a motion that is already ongoing for every particle in the universe. There is a way of thinking about interstellar travel that is less about technology and more about character. The character of a journey that takes longer than a human lifetime, that covers distances that make every earthly scale irrelevant, that requires not speed but patience as its essential condition. This way of thinking does not begin with engines or fuel or the mathematics of trajectory. It begins somewhere quieter than that. It begins with the recognition that the four companions of any interstellar voyage are not obstacles or resources. They are the nature of the journey itself. They are what the journey is made of, the way a river is made of its water and its banks, and its slow, persistent direction toward the sea. Most journeys are defined by their destinations. You travel to arrive somewhere, and the arriving is the point, and the traveling in between is the price paid for the arriving. But an interstellar journey resists this framing. The destination, if there is one, is so far away and so long in arriving that organizing the entire meaning of the journey around it would leave the travelers. And any generation ship carries travelers across many generations without a meaningful present, always deferred toward a future that none of the current generation will live to see. The interstellar journey, perhaps more than any other kind of journey imaginable, demands a different relationship with the act of traveling itself. It demands that the traveling be the point, that the space between departure and arrival be understood not as empty time, but as the full substance of the experience. Distance is not the enemy of interstellar travel. It is its medium. Without the distance between stars, there would be no interstellar travel. There would be nothing between the stars to travel through. The distance is what the journey is made of, the substance of the experience, the quality that gives the voyage its particular character. This may seem like a subtle distinction, but it carries real weight when held quietly. A journey through enormous distance is a different kind of experience from a journey through small distance, not just longer, but different in its texture, its relationship with time, its effect on the traveler's sense of place and self. The traveler who has accepted the distance, not merely tolerated it, not simply endured it, but genuinely accepted it as the medium through which they are moving, is a different kind of traveler from one who is waiting for it to end. The distance is the gift as much as it is the challenge. It is the room in which the whole of the experience takes place. Consider what it would mean to truly accept a distance of 4 light-years. Not to measure it, not to calculate how long it would take to cross at any given speed, but to simply hold it as the quality of the space between here and there, the texture of the gap between one warm star and the next. 4 light-years is the distance that light, the fastest thing the universe has ever produced. The fundamental speed limit of all information and all causation takes more than 4 years to cross. The human mind can state this. It can do the arithmetic. But accepting it, feeling it as a quality of space rather than a number in an equation, requires a slower kind of attention, the kind that interstellar travel, in its long, patient way, would eventually provide. Patience is not a virtue that interstellar travel merely requires. It is a condition that interstellar travel embodies. The universe, in its structure, is patient in a way that no individual entity can fully match, but that everything can, in some partial way, participate in. The stars are patient. They burn for millions and billions of years, fusing hydrogen into helium, helium into heavier elements, converting mass into energy at a rate so slow that a star like the Sun has been doing it for nearly 5 billion years, and has enough fuel remaining for roughly 5 billion more. The stars do not hurry this process. They do not attempt to burn brighter and end sooner. They simply burn at the rate that the physics of their mass and pressure and temperature determine, and the result is a lifetime so long that human civilization, placed within it, barely registers as a duration at all. The interstellar medium is patient in the same way, though it expresses its patience differently. It drifts. Its hydrogen atoms move slowly through the enormous spaces between stars, occasionally interacting with other atoms, occasionally being swept up by the gravitational influence of a passing cloud or a nearby star, occasionally participating in the slow collapse that eventually produces new stars. But mostly the interstellar medium simply drifts, occupying its thin and ancient space without urgency, without any particular direction, without any schedule to keep. It has been drifting, in various configurations, for billions of years. It will continue drifting for billions more. Its patience is not a quality it has cultivated. It is simply what the interstellar medium is the most patient environment the universe has managed to produce, which is saying something in a universe that has been producing patient environments for 14 billion years. The light crossing the space between stars is patient. It does not hurry. It does not slow down. It simply continues at its one constant speed through whatever medium it finds, without urgency, without complaint, arriving eventually at whatever receives it. This is a form of patience that operates without any subjective experience of patience, which makes it, in a way, the purest form of patience available. Light does not feel the crossing. It does not experience the years of travel as years. For light itself, if the word "for" is even meaningful in this context, there is no duration. The journey from the nearest star to Earth takes more than 4 years by the reckoning of any clock on Earth. But for the photons making that crossing, the physics of relativity suggests that the journey takes no time at all. Light arrives at its destination in the same moment it departs, from its own perspective, having crossed 4 light years in a subjective instant. An interstellar traveler who has internalized the patience of the journey is not waiting for it to end. The journey is the condition, and patience is the appropriate relationship to it, not as a discipline imposed from outside, not as a virtue practiced against the grain of some opposing impatience, but as the natural response of a mind that has genuinely understood what kind of space it is moving through. Impatience in interstellar space would be like impatience with the fact of gravity, a feeling directed at a feature of reality so fundamental and so permanent that the feeling could find no purchase anywhere. The journey is long because the distance is large. The distance is large because this is how the universe has arranged its stars. And the universe has arranged its stars this way for reasons that have nothing to do with any traveler's preferences or schedule. Light is the messenger and the measure of all interstellar things. It is the fastest information available, and even it takes years to carry news between the stars. It is also the source of the visual richness of the universe. The stars are visible because they emit light. The clouds of gas and dust between stars are visible because they scatter or absorb or emit light in various ways. The galaxies are visible because they are collections of billions of light-emitting stars, each one contributing its small, steady output to the aggregate glow. Everything known about the universe beyond the immediate neighborhood of Earth has been learned through the reception and careful analysis of light in its various forms. Visible light, radio waves, infrared, ultraviolet, X-rays, gamma rays. All of these are forms of the same fundamental thing, electromagnetic radiation, traveling at the same fundamental speed, carrying information from its source to whatever receiver happens to be in the right place at the right time. Light is the universal medium of cosmic communication, patient and constant, available to any receiver in any direction, crossing the interstellar medium without significant degradation at the one speed the universe allows. A message sent by light from a civilization around another star would take years to arrive, but it would arrive, and it would carry its information intact, having crossed the interstellar medium without losing anything essential. The thinness of the interstellar medium, which makes it such a quiet and patient environment for travelers, also makes it almost perfectly transparent to light. A photon of visible light can cross the galaxy largely unimpeded, encountering dust and gas only rarely, traveling its enormous distance with most of its energy preserved. Light, in this sense, is the one thing that finds interstellar distances easy. Time is the companion that an interstellar traveler lives within more consciously than any person anchored to a planet can. Because on an interstellar journey, time is not abstract. It is the substance of the experience. Every day of travel is a day of distance covered, a day of new interstellar medium passed through, a day of the destination star, brightening by a fraction too small to notice in a single observation, but accumulating over years into a measurable change. Time does not drag on an interstellar journey in the ordinary sense of dragging it. It's simply present, unfolding at its steady rate, accumulated over years and decades and centuries into the larger shape of the voyage. The traveler's relationship with time on an interstellar journey is the same as the universe's relationship with time in general, not fighting it, not trying to compress or expand it, simply inhabiting it fully as the medium in which all experience takes place. The universe, as a whole, is not urgent. Nothing in the structure of the cosmos suggests that things need to happen quickly. Stars form over millions of years, in the slow gravitational collapse of molecular clouds that takes longer than many civilizations last. Planets form over millions more, from the gradual accumulation of dust and rock in the disk of material that surrounds a young star, each collision and accretion, adding incrementally to the growing mass until something large enough to be called a planet has assembled itself from what was previously scattered and formless. Life, where it exists, appears to develop over hundreds of millions to billions of years, each step of increasing complexity taking geological ages, each new capability arising not by design, but by the slow accumulation of small advantages over enormous spans of time. Civilizations, on the scale of cosmic time, are brief and remarkable concentrations of complexity in the long and otherwise gradual process of stellar evolution. The universe has been here for nearly 14 billion years, and civilizations, as far as any evidence shows, are a relatively recent development products of the last few percent of cosmic time. Brief flickers of organized matter that have somehow become aware of the universe that produced them. The universe will continue, by current understanding, for many orders of magnitude longer than it has already lasted long past the end of all stellar activity. When the last red dwarf has slowly cooled into darkness, long past the dissolution of all galaxies into dispersed clouds of cooling remnants, into a future so remote and so unlike the present that the word future barely contains it. Against this background, an interstellar journey that takes 1,000 years is not long. An interstellar journey that takes 10,000 years is not long. Even the journeys measured in millions of years that a slowly drifting spacecraft might take are, on cosmic scales, a brief passage, a minor interval in the larger motion of things. Everything is proportional to the timescale of the universe itself, and the universe's timescale is not something the human mind can hold completely, but can quietly acknowledge as the backdrop against which all human urgency appears as what it genuinely is, a local condition, specific to this particular evolved biology, on this particular planet, in this particular moment, of this particular galaxy's long and ongoing life. Urgency is not a feature of the cosmos. It is a feature of creatures whose lives are short relative to the timescales on which everything else operates. The cosmos does not share the urgency. It has never needed to. The four companions that have traveled through this night's journey distance, patience, light, and time, are not travelers' companions in any exclusive sense. They are the companions of everything. They are the conditions within which the entire universe operates, the permanent features of any space and any moment that has ever existed or will ever exist. Distance exists between every object and every other object in the cosmos, from the distance between two hydrogen atoms in the interstellar medium to the distance between galaxy clusters separated by hundreds of millions of light-years. Patience is the quality of everything that continues without urgency through the long unfolding of time, which is to say, the quality of almost everything in the universe, almost all of the time. Light connects all things that emit and receive electromagnetic radiation, which includes everything that has temperature, which includes everything, and time surrounds and pervades all events, all objects, all processes, giving them their sequence and their duration, making before and after meaningful, making change possible, making the universe a story rather than a static arrangement. An interstellar journey is simply the moment at which a traveler becomes consciously aware of the companionship of these four qualities, the moment at which they become too large to treat as background, too present to be ignored, too fundamental to be abstracted into numbers on a page. In ordinary life on a planet, distance is small enough that patience is rarely required for the crossing of it. Light arrives from across the room, across the city, across the world, in intervals too short to experience as intervals at all. Time moves at a rate that feels, if not exactly manageable, at least familiar, a rate calibrated by evolution to the rhythms of a day and a season and a lifetime. But in interstellar space, all four companions expand to their full natural scale. The traveler finds themselves inside something very large and very quiet and very old, accompanied by the same forces that have governed everything from the first moments of the universe to this particular moment, in this particular ship, crossing this particular gulf between two particular stars. Everything is already in motion. Every atom in the universe has been in motion since the universe began, and will continue in motion in some form, for as long as the universe has structure enough to support motion of any kind. Interstellar travel is not the imposition of motion on something stationary. It is the direction of existing motion toward a chosen end, the shaping of what was already happening into something intentional, the conversion of orbital velocity and launch energy into the clean, linear drift of an interstellar trajectory. The interstellar traveler, real or imagined, is not departing from something settled into something uncertain. They are simply exchanging one form of motion for another, the curved orbital motion of a planet for the long, straight drift of a ship in the open interstellar medium, the daily cycle of a rotating world for the steady and unvarying continuation of a vessel moving through the quiet between suns. The underlying condition is the same in both cases: motion through a universe that is itself in motion, surrounded on all sides by the four companions, accompanied by the long and patient physics that governs everything without exception, from the smallest particle to the largest structure the universe has yet produced. There is no urgency in cosmic structure. There never has been. The universe does not have a deadline. It does not have a schedule it is trying to keep, or a destination it is trying to reach before some particular time. It expands at its own rate, determined by the initial conditions of its beginning and the properties of the dark energy that permeates it. It forms its stars in its own time, when the conditions in a molecular cloud happen to cross the threshold that initiates gravitational collapse. It allows its planets to develop whatever character they develop over whatever time it takes, without any external pressure to develop faster or differently. And it extends the same patience, the same absolute, structural, unconditional patience to any small craft that might someday move through the interstellar medium, covering its light years at whatever pace the physics of the available propulsion allows, accompanied by the same companions that have accompanied everything that has ever moved through the space of this universe. Distance waits, as it has always waited, as it will always wait, unchanged and unchanging, the permanent gap between one warm point of light and the next. Patience endures, not as a quality that can be exhausted or depleted, but as the simple condition of a universe that has more time than anything could ever use. Light crosses, as it always crosses, at its one steady speed, carrying its news from wherever it was released toward wherever it happens to arrive, without preference, without urgency, without rest. Time flows, surrounding everything, threading through every event and every object, making the universe a sequence rather than a simultaneity, giving every journey its beginning and its middle and its long, unhurried continuation. And everything continues. Everything, always, continues. The ships are still out there, moving through the dark beyond the heliopause, carrying their golden discs and their quiet instruments into the interstellar medium. They will be moving tomorrow and next year, and in 1,000 years, and in 10,000 years. They do not need your attention to continue. They are already on their way, as they have been for decades, as they will be for millennia. No one needs to watch them for the motion to remain real. No one needs to track their signals for the distance to continue accumulating, light minute by light minute, year by patient year. There is something quietly remarkable about that. A machine built by human hands, assembled from materials mined from the earth and shaped by human tools in human buildings on a human timescale, is now so far from all of that the concept of human scale no longer applies to it in any meaningful way. It belongs to interstellar space now, in the same way that a leaf released into a river belongs to the river, not claimed by it, not consumed by it, but carried, gently and without interruption, in whatever direction the current runs. The current here is the residual motion of a launch that happened decades ago. The river is the interstellar medium, thin and cold and ancient, and it does not resist the leaf at all. The stars are still out there, each one a sun with its own particular warmth and its own particular neighborhood of space, separated from the next by years of light, patient in their burning, indifferent to whether anyone is watching. The nearest ones are sending their light right now, as they always are, and that light is crossing the interstellar medium as you rest, as you breathe slowly, as the edges of your awareness soften and the grip of the day loosens into something quieter. That light left its source years ago. It has been traveling through the same thin interstellar medium that the small spacecraft are now crossing, moving at the one speed the universe allows, steady and uninterrupted, carrying no message and no intention, simply continuing because continuing is what light does. By the time it arrives at the upper atmosphere of Earth, it has crossed more than 4 light-years of open space. It enters the atmosphere and is scattered slightly, softened, diffused by the thin layers of air that make the sky appear blue in daylight and dark at night. It passes through cloud or through clear air depending on the particular night. And then it arrives at the surface, at the window of a room, at the closed eyelid of someone lying still in the dark, arriving quietly, without announcement. The same light that left a small red star years ago, completing its long and patient crossing without any fanfare at the end. You do not need to follow the journey to its end tonight. There is no end tonight. The journey continues, whether followed or not, at its own pace, in its own direction, through the same patient distance and the same ancient medium that it has been crossing since before any of this was put into words. The four companions' distance, patience, light, and time are not waiting for any traveler in particular. They are simply there, as they have always been, the permanent conditions of a universe that has never been in a hurry and never will be. They were there before the first human looked up and wondered about the stars. They will be there long after the last question about them has been asked. Distance does not diminish when no one is measuring it. It simply exists, as it has always existed, between every object and every other object in the cosmos. The distance between the sun and the nearest star is not maintained by any effort. It is not held in place by any intention. It is simply the current state of the space between two gravitational objects that happen to be separated by a particular amount of emptiness, and it will change only slowly, over millions of years of stellar drift, as both stars continue their slow and separate paths through the galaxy. In the meantime, the distance simply is. It asks nothing of anyone who notices it. Let the spacecraft drift outward in their slow and quiet trajectories. Let the stars remain at their great removes, burning patiently, sending their light without expectation of receipt. Let the interstellar medium hold its thin and ancient quiet, its single hydrogen atoms drifting through distances that no word quite captures, its magnetic fields threading the emptiness with their faint and ancient structure. There is no instruction required for any of this. The universe has been running its own processes for 14 billion years without any assistance, and it shows no sign of needing any now. The interstellar medium holds its quiet not because it is trying to be quiet. It holds its quiet because quiet is what happens when there is almost nothing. When the nearest particle to any given particle is separated from it by a distance that would seem vast on any scale, a human body can, intuitively, understand. There is no mechanism for noise in a space that thin. No wave can propagate without a medium dense enough to carry it. The silence of interstellar space is not an absence of something that should be present. It is the natural condition of a space that has more emptiness than anything else, and it is as complete and as permanent as any physical condition in the universe. The galaxy will continue its slow rotation, whether you are watching or not. The sun will continue its orbit around the galactic center, as it has been doing for nearly 5 billion years, as it will do for billions more. One full orbit takes roughly 225 million years, a span so large that the human mind can acknowledge it without truly feeling it, the way you can acknowledge the depth of the ocean without feeling the weight of all that water. The sun does not hurry this orbit. It does not have a schedule to keep. It simply moves at its current velocity, in its current direction, responding to the combined gravity of everything in the galaxy, as it has always moved, as it will always move, for as long as the galaxy maintains its current structure. The nearest star will continue its slow, proper motion across the background of more distant stars, shifting by a tiny fraction of a degree every century, patient and continuous. In a few tens of thousands of years, it will no longer be the nearest star, another star, currently farther away but moving on a trajectory that will bring it closer, will take that title for a long period before drifting away again. The stars of the solar neighborhood are not fixed in their relationships. They are all moving, all drifting on their individual paths through the galaxy, and the particular configuration visible from Earth tonight is one frame in a very long and very slow motion, a snapshot of a gravitational dance that has been ongoing for billions of years and will continue for billions more. And you, in this particular moment, in this particular room, on this particular small planet, orbiting this particular star, are already a participant in all of it, already moving, already accompanied by the four companions, already part of the long and patient story of a universe in no particular hurry. The Earth carries you around the Sun at roughly 30 kilometers per second. The Sun carries you around the galactic center at roughly 230 kilometers per second. The galaxy carries you through the local group of galaxies at its own velocity. You have never been still, not for a single moment of your life, not for a single moment of any life that has ever existed on this planet. Motion is the condition you were born into and have never left. This is not unsettling. It is, in the quietest possible way, a kind of company. You are not alone in your motion. Every star in the galaxy is moving alongside you, each on its own path, each at its own pace, each accompanied by the same four companions that travel with everything in a universe built on the geometry of space-time and the long, slow pull of gravity. You share your motion with the 5 small spacecraft beyond the heliopause. You share it with the hydrogen atoms drifting through the interstellar medium. You share it with the photons of starlight currently crossing the final fraction of their 4 light-year journey. Everything that exists is in motion, and nothing is alone in that motion, even across the distances that make the word alone seem like it might apply. The light from distant stars is arriving right now, crossing the final fractions of its interstellar journey, entering the atmosphere, filtering through whatever lies between you and the sky, present even if unseen. It has been traveling for years or centuries or millennia to arrive at this particular night, and it continues past this night without slowing, without losing its quiet direction. Light does not stop at the surface of a closed window. It does not pause at the edge of a cloud. It simply continues, those parts of it that are not absorbed continuing onward, deeper into the atmosphere, or through it entirely, carrying the news of a distant sun across the last few meters of a journey that began light years away. There is something very gentle about this, if you allow it to be gentle. Ancient light, completing its crossing. A journey measured in years, reduced to its final moments as it passes through the last thin layers of air and arrives. No destination required it. No receiver was expected. It simply came because light, once released, continues until it meets something that absorbs it. And the something it meets might be anything: a detector, a leaf, a sleeping face, the dark side of a mountain, the cold surface of the ocean. All of these are equally valid ends to the same long journey. All of them complete the crossing without any drama. There is nothing more to attend to. The universe does not need your attendance. It simply continues, as it has continued for 14 billion years, as it will continue for incomprehensibly longer, full of its patient distances and its quiet light and its 4 great companions, moving at the pace of something that has all the time there is and knows it. The processes that will shape the next billion years of this galaxy are already in motion, already determined by conditions already in place, already unfolding at the slow and stately pace of stellar physics and galactic dynamics. Nothing about that unfolding requires observation. Nothing about it depends on any individual awareness remaining open to receive it. You are allowed to close. You are allowed to let the awareness soften past the point where it can follow anything. The ships will continue without being followed. The stars will burn without being watched. The interstellar medium will hold its quiet without any witness to confirm its quietness. The galaxy will rotate another fraction of a degree tonight, imperceptible, patient, indifferent to whether the rotation is noticed or not. Your breathing slows. Each breath out is a small release, a small letting go of whatever the day left behind, a small movement toward the long and patient stillness that the universe models so well in the space between its stars. Your thoughts soften at their edges, becoming less specific, less attached to any particular concern or any particular image, drifting the way interstellar dust drifts, not toward anything, not away from anything, simply in the direction the slow forces of the moment carry them. The interstellar medium holds its quiet. The small travelers drift outward, gold discs and aging instruments, moving through a dark that has no edge they will ever reach. The stars remain, each one a sun, each one surrounded by its enormous silence, each one continuing its long nuclear patience without any requirement that anyone acknowledge it. The four companions remain as they always remain, distance everywhere, patience in everything, light crossing every dark, time flowing alongside all of it without urgency or interruption. Everything continues gently, whether noticed or not. Everything is already exactly as patient as it needs to be. And so, for now, are you. Sleep well, and good night.